Use case points. UCP is a software estimation technique used to forecast the software size for software development projects. UCP is used when the Unified Modeling Language (UML) and Rational Unified Process (RUP) methodologies are being used for the software design and development. The concept of UCP is based on the requirements for the system being written using use cases, which is a part of the UML set of modeling techniques. The software size, UCP, is calculated based on elements of the system use cases with factoring to account for technical and environmental considerations. The UCP for a project can then be used to calculate the estimated effort for a project. History. The UCP technique was developed by Gustav Kahner in 1993 while employed at what was known at the time as Objectory Systems, which later merged into Rational Software and then IBM. The UCP method was created to solve for estimating the software size of systems that were object-oriented. It is based on similar principles as the function point estimation method, but was designed for the specific needs of object-oriented systems and system requirements based on use cases. Method. The method for determining the size estimate to develop a system is based on a calculation with the following elements. Unadjusted use case weight, UUCW, the point size of the software that accounts for the number and complexity of use cases. Unadjusted actor weight, UAW, the point size of the software that accounts for the number and complexity of actors. Technical complexity factor, TCF, factor that is used to adjust the size based on technical considerations. Environmental complexity factor, ECF, factor that is used to adjust the size based on environmental considerations. Once the previous four elements have been calculated, the final size estimate can be calculated. This final number is known as the use case points or UCP for a software development project. The following sections walk through the various calculations to determine the UCP for a project. Unadjusted use case weight, UUCW. The UUCW is one of the factors that contribute to the size of the software being developed. It is calculated based on the number and complexity of the use cases for the system. To find the UUCW for a system, each of the use cases must be identified and classified as simple, average, or complex based on the number of transactions the use case contains. Each classification has a predefined weight assigned. Once all use cases have been classified as simple, average, or complex, the total weight, UUCW, is determined by summing the corresponding weights for each use case. The following chart shows the different classifications of use cases based on the number of transactions and the weight value assigned for each use case within the classification. UUCW equals total no of simple use cases x5 plus total no average use case x10 plus total no complex use cases x15. Unadjusted actor weight, UAW. The UAW is another factor that contributes to the size of the software being developed. It is calculated based on the number and complexity of the actors for the system. Similar to finding the UUCW, each of the actors must be identified and classified as simple, average, or complex based on the type of actor. Each classification also has a predefined weight assigned. The UAW is the total of the weights for each of the actors. The following chart shows the different classifications of actors and the weight value assigned. UAW equals total no of simple actors x1 plus total no average actors x2 plus total no complex actors x3. Technical complexity factor, TCF. The TCF is one of the factors applied to the estimated size of the software in order to account for technical considerations of the system. It is determined by assigning a score between 0, factor is irrelevant, and 5, factor is essential, to each of the 13 technical factors listed in the table below. This score is then multiplied by the defined weighted value for each factor. The total of all calculated values is the technical factor, TF. The TF is then used to compute the TCF with the following formula. TCF equals 0.6 plus TF, 100. Environmental complexity factor, ECF. The ECF is another factor applied to the estimated size of the software in order to account for environmental considerations of the system. It is determined by assigning a score between 0, no experience, and 5, expert, to each of the 8 environmental factors listed in the table below. This score is then multiplied by the defined weighted value for each factor. The total of all calculated values is the environment factor, F. The F is then used to compute the ECF with the following formula. ECF equals 1.4 plus minus 0.03 xf. Use case points, UCP. Finally, the UCP can be calculated once the unadjusted project size, UUCW and UAW, technical factor, TCF, and environmental factor, ECF, have been determined. The UCP is calculated based on the following formula. UCP equals UUCW plus UAW x TCF x ECF. Example. To illustrate the process of calculating the UCP, an online shopping system will be used. The diagram below depicts the use case diagram for the system to be developed. Unadjusted use case weight, UUCW. To calculate the UUCW, the use cases must be defined and the number of transactions for each use case identified. The online shopping system use case diagram is depicting that 9 use cases exist for the system. Assuming 2 of these use cases are simple, 3 are average and 4 are complex. The calculation for UUCW is as follows. UUCW equals total no of simple use cases x5 plus total no average use cases x10 plus total no complex use cases x15. For the online shopping system, the UUCW equals 2 by 5 plus 3 by 10 plus 4 by 15 equals 100. UUCW equals 100. Unadjusted actor weight, UAW. To calculate the UAW, the actors must be identified. The online shopping system use case diagram is depicting 5 actors. 1 simple for the payment processing system and 4 complex for each of the human users actors, i.e., online customer, marketing administrator, warehouse clerk, warehouse manager. The calculation for UAW is as follows. UAW equals total no of simple actors x1 plus total no average actors x2 plus total no complex actors x3. For the online shopping system, UAW equals 1 by 1 plus 0 by 2 plus 4 by 3 equals 13. UAW equals 13. Technical complexity factor, TCF. To calculate the TCF, each of the technical factors is assigned a value based on how essential the technical aspect is to the system being developed. The diagram below shows the assigned values for the online shopping system. The values are multiplied by the weighted values and the total TF is determined. Next, the TCF is calculated. TCF equals 0.6 plus TF 100. For the online shopping system, TCF equals 0.6 plus 42/100 equals 1.02. TCF equals 1.02. Environmental complexity factor, ECF. To calculate the ECF, each of the environmental factors is assigned a value based on the team experience level. The diagram below shows the assigned values for the online shopping system. The values are multiplied by the weighted values and the total F is determined. Next, the ECF is calculated. ECF equals 1.4 plus minus 0.03 XF. For the online shopping system, ECF equals 1.4 plus minus 0.03 asterisk 10.5 equals 1.085. ECF equals 1.085. Use case points, UCP. Once the unadjusted use case weight, UUCW, unadjusted actor weight, UAW, technical complexity factor, TCF, and environmental complexity factor, ECF, has been determined. The use case points, UCP, can be calculated with the following formula. UCP equals UUCW plus UAW x TCF x ECF. For the online shopping system, UCP equals 100 plus 13 x 1.02 x 1.085 equals 125.06. UCP equals 125.06. For the online shopping system, the total estimated size to develop the software is 125.06 use case points. Now that the size of the project is known, the total effort for the project can be estimated. For the online shopping system example, 28 man-hours per use case point will be used. Estimated effort equals UCP x hours, UCP. For the online shopping system, estimated effort equals 125.06 x 28. Estimated effort equals 3,501 hours. Further development. One major weakness of the use case points method is that it has never been thoroughly calibrated using regression analysis due to a lack of a statistically sufficient number of projects. Moreover, the linear model of Kahne's approach does not take the diseconomies of scale into account that occur in software development projects. Still, the easily applicable sizing approach and counting rules provide many benefits for estimations in early phases and thus allow to quickly yield the FSM, functional size measurement, in this case UUCW plus UAW, of an application or IT product. This FSM can then be combined with statistically validated estimation models like COCOMO22. Gain more reliable estimation results. See also, use case modeling, function point, software estimation, software development effort estimation, advantages of function point analysis in relation to use case points, an estimation approach, estimating software via use cases, improving consistency of use case points estimates. Clemens, Roy K. Project Estimation with Use Case Points. Crosstalk Feb. 2006.